This conference will now be recorded.
Hi everyone. We will now learn a concept known as multiple regression. In the previous video, we have seen this table. Here we have one independent variable and one dependent variable. And then we have also seen another table. In this table also, we have one independent variable and one dependent variable. But look at this table. Have a look at this table. Here we have several independent variables. We have several independent variables. Research and development spending, right? Administration spending, marketing spending, and so on. So here in this data set, we have the data about many companies. How much does the particular company spend for research and development? How much does it spend for administrative expenses? How much does it spend for marketing? And where is it located? On the basis of these values, we have to predict the profit that it is likely to get. So what do we predict? Profit. So that is the dependent variable. All other variables are independent variables. Now in all the previous examples, we have only one independent variable. Now we have several independent variables. Whenever we have several independent variables, we have to talk about multiple regression. When we have only one independent variable, we talk about simple regression. When we have many independent variables, we talk about multiple regression. Now in this example, we are going to learn two new concepts. Number one, how to deal with many independent variables. Number two, here, look at this column. The values are not numeric. See, all these values are numeric, all these values, but these values are not numeric. So, but only when these values are converted into numeric values, the regression algorithm will work. Regression algorithm will work only if all the data are numeric values. Now, see, if you carefully look at these values, New York, California, and Florida get repeated. So you can pick out all the companies which are located in New York and form on group, right? One form on category. Similarly, you can pick out all the companies which are located in California and form a second category. And similarly, you can form a third category of companies which are located in Florida. Now this this variable helps us to categorize the companies. One category of company located in New York, another category of companies located in California, third category of companies located in Florida. That is why it is known as categorical variable. The values of a categorical variable should be converted into numeric values. Such process is known as one-hot encoding. That is also going to be learned. Let us have a This is the program we are going to use. See, we are importing the various libraries. This is our data set. We all just now seen it, Now, the fourth column is the dependent variable. Let us have a look at the table. Fourth column, zeroth column, first column, second column, third column, fourth column. Fourth column is our dependent variable. And 0 to -1 in Python, -1 means last column. When you write 0 to last column, you should start with 0th column and you should stop with last but one column. You know very well in Python, if you write 4 here, right? If you write 4 here, you should stop with 3. If you write 4 here, right? You should stop with 3. If you write 5 here, you should stop with 4. Similarly, if you write -1 here, -1 means last column, you should stop with last but one column. So let us have a look at the table once again. You should start with the 0th column. You should proceed. Consider this one, this one, this one. Where should you stop? You should stop here because this is the last column. You should stop with the last. This is the last but one column. So what do we tell the system? This column, this column, this column, this column, 0th column, first column, second column, third column together constitute the independent variables. So we have read in the data, we have defined the independent variable, we have defined the dependent variable, and then this is known as one-hot encoding. See, one-hot encoding process. Why do we write it? Because all the values are in this column or to be converted into numeric values, or to be converted into numeric value. That is why we are writing like this code. Let us not worry about it. We are mentioning the column number, you see, column number 3. Here also we write column number 3. What is column number 3? 0th column, first column, second column, column. So what do we say? Column number values in column number 3 are to be converted into numeric values. Okay. And then we divide the data set into 2 portions, right? The idea is very simple. How many rows do we have? We have 400, sorry, we have 50 rows. The number is 51, but the first row should not be considered because it contains the column heading. 50 rows. The idea is very simple. We are going to use 40 rows which are randomly selected from this one to find the relationship between x and y. We are going to use, see, we have to find the relationship between x and y. For that purpose, we will use 40 rows, and we will use the remaining 10 rows to find out how accurate our result is. See, test size is equal to 0.2. That means 20% of the data set will be used for testing. How many rows do you have? You have 50 rows. What is 10% of 55? 20% of 50, 10. That is why I say 10 rows will be considered for testing. Remaining 40 rows, usually more number of rows will be used for finding the relationship. See, X train will contain 40 rows, right? Values of 40 rows. Similarly, Y train will also consider the Y values in 40 rows and use 40 rows to find the relationship. Use the remaining 10 rows to test it. And then we do the prediction. And then I will explain the remaining part of the code at the time of execution. Now we will move over to Google Colab, right? We will create a new code block. Let us paste it. We need this table. So first of all, let us upload it, right? Startups. That's a table we want. Startups.csv. We are defining the independent variable. Dependent variable, we are doing the encoding. It is known as one hot encoding. Now no error is reported. Now let us go back and fetch some more code, right? Now what are we doing? We are dividing the data into 2 portions, and then we are finding the relationship between x and y. Regression equation is nothing but the functional relationship between x and y, and then we are finding the regression coefficients. We are finding the predicted values, and we find the R square. I already told about R square. What does it mean? It tells you how accurate. See, let us not worry about these values. See the accuracy, right? If we see this function provides 94% accurate values. In other words, this function is based on this algorithm. This algorithm provides 94% accurate values as far as this data set is concerned. 94% accuracy is really something very good. So we confidently move forward. What do? We decide to use it for prediction. Once we know that our model is really very good, really very reliable one. Now, one company says they are spending 1,45,000 for research and development, and 1,20,000 for administration, and 3,85,000 for marketing, and they are located in California. They asked me one question: how much profit can we expect? Similarly, the data for second company, data for third company, all this data are right used to form a dictionary, and this dictionary is used to form a table. And then I say all the values in this table, all rows, all columns will form my independent variable. Please carefully note, I don't talk about the dependent variable. What is the dependent variable? It is the profit. Why I don't talk about the dependent variable? That is what I am going to predict. When the values of the independent variables are given, we are going to predict the dependent variable. Now we do one hot encoding, and then when x is given, what is x? Independent variable. We will get the predicted value of y. Let us execute. We will get the predicted values of y. You see, the first company is likely to get $1,72,747 as profit. Similarly, this is the profit for second company. This is the profit for third company. So we really had a very good idea about multiple regression. See, step one, we read in the data, we do encoding. We have learned two important concepts. How do we deal with multiple, right, independent variables? How do we deal with categorical variables? Now we really have very good idea. Now you can see, pause the video and generate data. I have shown part of the data, you can generate similar data. Similarly, I have also shown the code. You can pause the video, and write the code also. Now getting the code, getting the data set is not at all an issue. Understanding the code, understanding the concept is very important. I hope that this video would have helped you to understand the code. Thank you very much.